Ah, Shop. I've missed you. Okay. Swords are not supposed to be in a CNC machine. So I guess we're making a sword rack. We're going to try something new today on Hands on CNC. I'm going to give you guys an agenda with time codes, so feel free to jump to the part you're interested in. That being said, we're also going to cover kind of the whole workflow from idea to thing. So if you're new to CNC machines and digital fabrication, watch the whole video. If you have friends that are new and you're trying to explain things, great intro video of this is what CNCs do. So we're going to cover, obviously, the design itself in Fusion 360. We're going to jump into Fusion 360's CAM area. We'll talk about how we made the cut operation choices we made. Then we're going to do the construction. You can watch some construction videos. It's ubiquitous. They have to be construction videos. And then we'll kind of review the results, talk over what we learned, and one of the coolest parts of this particular video, links in the description to the actual Fusion 360 file if you want to make a sword rack. And if you don't want to make a sword rack, but you want a sword rack, we actually make these sword racks for people. So link to our Etsy store if you want a sword rack. So stick around and let's jump into the Fusion 360. All right, so here's our sword rack, kind of starting from the end design-wise, because I've already made these. I make these, so backwards maybe. But the reason we use a CNC to make this, it looks like a very simple part. It really is a simple part. There is some interesting geometry up here. This geometry is a little interesting, and it would be a little difficult to do by hand. Not impossible, but that's what robots are great at. So what CNC machines are great at is doing a little bit of complicated geometry and then making it absolutely consistent. So there's some geometry up here that allows you to lock the legs around the leg holes, kind of like a vise. I'm going to show you what that looks like in a second. And then there's matching geometry at the bottom, so when the legs are open, they're flat. And so the idea is you take two legs, you flip one backwards to the other. So you really only have two parts to this whole thing. You have the body and you have the leg. Now, I have a couple versions of the body. I happen to. You don't have to have. It's just my own thing that I have a couple versions of bodies, an all oval. There's an all circle, and then I have a circle oval. But the legs don't change. It's a nice thing. It's one leg design. Get the math right, and then it works out. So when I say get the math right, what does that look like? Well, I kind of put together a little operating example here so we can talk about that. So let's go here. Let's go back to home. Let's flip around to where my sample is. And so you can change our view a little bit, maybe make this a little more visible. Let's start with just there we go. So you can kind of see this leg fits through here and then clamps. And if we go to this view here, you can kind of get an idea how the leg goes through, and it opens up, and there's a little ledge at the bottom, and then that little radius comes over. And if I hide the body, wrong one. If I hide the body, you can see what we essentially get are like little pairs of pliers squishing down and holding the sword rack itself in place. So we give the sword rack a ledge to sit on, and then we give it a little squeeze to push it down into that ledge. And if the more this leg pushes down onto this leg's ledge, the more this leg, right, pivots and pushes down in reverse. So you get a clamping action. It's there and it's clamping. And if we operate this joint or drive it, when it's closed up, it's a nice simple piece of material. It's actually bigger down here. It's bigger than the hole. So it'll slide through, and as it slides through, it'll actually start to force this open, and then it'll clamp in place. It'll get to a point where it can't go any further. It'll clamp into place, and it'll actually kind of firm up and be a nice rigid support. So that's a little bit of fiddly geometry that we did. So the sword rack originated from one friend showed another friend. So shout out to in the SCA, Master Aaron Harper, who came up with like the first design of these, and then Master Yago, who came up with his version, and then I kind of took his version and So I have a CNC machine. I can do this because he did some very simple tooling, like a very, very easy one. But there were some challenges to hand shaping and some other things. Didn't have this clamping geometry. Couldn't quite firm it up. So if you're in the SCA, you might know who those guys are. If you're not in the SCA, don't worry about it. They're wonderful individuals, and thank you for their kind of evolution of this to the point we're at. So there we have it. Let's talk about how we got here. If you're new to Fusion 360, if you've never heard of Fusion 360, it's a 3D CAD CAM software, so 3D design and computer-aided machining, so basically instructions. We're going to cover that in a second. Go download it if you haven't. It's not free. It's free for students and hobbyists, and then if you make enough money, you do need to pay for it, although the price is not that bad. So when we work on something like this, we actually work on it first with sketches. And so we're going to look at those sketches real quick. So the base is very simple, right? I mean, it's a rectangle based on the size of material we want. Some holes in that. This hole is a specific size to match up to what's going on with this travesty over here, which is the leg. And we just tell them Fusion 360 to extrude. So you can imagine just if this was our template, we're just pulling that template into three-dimensional space, and we can make a body out of this. In our case, we tell it to be 3/4 of an inch thick. Or if you're unlike the rest of the world and use proper SI units, it's times that by 25.4. Yeah, let's rotate that. No. Let's rotate that. There we go. All right. So there's your body. Now this fiddly bit over here, all of this noise makes the foot. Obviously, the part of the bottom makes sense, right? There's that angle. But what's going on up here is we're making a series of subdivisions to allow us to select just the part that we want to be the foot. And this is taken from some things. We wanted this to be a 30-degree angle, so that's 15. So 15 plus 15 because there's two legs, it gives us 30. Then if we want this line to kind of work with this line, so these are perpendicular here. This line is perpendicular to this line. We have a certain distance. We want this to be from this, so our material's 3/4 of an inch thick. So this kind of needs to be a little more than 3/4 of an inch. There's that top radius, that 1/8 inch radius, because we're going to use an 1/8 inch bit to round over the top. So we actually want this to shape, to curve and fit. A little bit of extra material to come over that ledge. And then we want this whole thing to be smaller when it's folded up than the hole that we're going into, which is obviously wider than the space. And so that's to do that and to make that narrowing shape. So this is some basic, just kind of fiddly work. But once you've done that and you're happy with it, you just extrude it like the body. So very, very simple model to make. And that kind of covers the model. It really is, it's one of those circumstances where it really is just that easy. And then you get a shape like this, and you put the body on it. You can see again, here's that wrap we're talking about, right? So there's it kind of fitting in and around and kind of clamping down. So now once I'm happy with my model, then what I'm going to do is I'm going to make my cutting layout essentially. So I'm going to take all my parts, I'm going to lay them out in a way that I cut them out. This is an interesting kind of thing you have to think about, is you have tools, you tool or bits that you're going to have moving around. So how do you space things to cut? Obviously, if I put this exactly next to that, exactly next to each other, what's going to go in between them to do cutting? So how do you work out that problem? In this case, it's pretty straightforward. I put a 1/4 inch between all these parts because I'm using a 1/4 inch bit, so one bit can kind of cut both sides. And then I have a special radiusing bit that I'll actually use to cut the soft turns. All that we're going to cover in CAM, so let's jump over to CAM. All right, so here we're on the CAM. CAM, computer-aided machining. So if you're new to this, this is how you tell the CNC machine, essentially the robot, exactly what to do. So we're going to tell it, I want you to take a specific bit to which I'm going to load in it because I don't have an automatic tool changer, and I want you to follow a given path. I want the RPM of the router to be a certain speed, and I want you to go through that path at a certain speed. So that's called your feed. So oftentimes you hear in CNC world, feeds and speeds. Feeds, how fast is the machine moving through the material? Speeds, how fast is the spindle spinning the bit, which we call the tool. So tool's a bit. Feeds are how fast it moves. Speeds is what's your RPM. In this project, are very simple. We are radiusing this part, so we're doing that by following we're telling it to take the center point of the bit and follow some lines, and we're telling it to follow those lines an eighth of an inch deep, and it's a special bit. You can see here that it's modeled that bit as a eighth inch radiusing bit. So that's a very simple job. If we go edit this and look, it really is a special bit which we've told Fusion 360 about. We want it to run at 20,000 RPM, and we want it to move a fairly slow 52 inches a minute, because it's a fragile, very small bit. It's literally going to a point. And we cut a lot of different materials, so it's kind of a safest path, right? We could be really efficient, but... So once we've radiused it, then we want to cut out all of our parts. So first step is we're going to do what's called a boring operation. It's a helixing operation. So very first step is we change our bit. You can notice the bit shape changes. And if we look here, we've actually changed our bit to a 1/4 inch bit. Now notice it's not actually a 1/4 inch bit. We've measured the bit, and while we thought we bought a 1/4 inch bit, we actually bought a bit that was a few hundredths smaller. And this is important because if I am a few thousand, I'm essentially a 100th smaller on all insides and a 100th bigger on all outsides, because if I cut this circle, the CNC machine is going to assume I have a certain thickness of bit. If I tell it it's a 0.25 thickness bit, it's going to move to cut 0.25. It's going to move the bit slightly to the inside because it thinks it's a bigger radius. So what happens is all of these circles become a 100th of an inch smaller. We're talking about 5 thousandths of an inch difference. It turns into a 100th because you have the problem on both sides, essentially radius, right? So all of our holes become a 100th of an inch smaller than we thought. Now that doesn't make a big difference in these big holes, but in these bores it makes a big difference, and it makes a big difference in these holes. Now why does it make a difference in these holes? There should be a 100th of an inch grace area. Well, these are a 100th of an inch off, too small. The outside corner has the same problem. The bit's moved slightly, so now the outside is a 100th of an inch too big. The result is the whole part is 100th of an inch, the 200ths of an inch too big. So we want to know exactly what bit we're using. We want the CNC to know exactly what bit we're using. We're going to save ourselves a ton of time in sanding and fitting parts together. And we're still going to sand and fit parts together, but we're going to save a lot of time. It's not going to be as bad. So we do the boring operation. Then we do a contour to cut out the insides, and you'll notice there's a little notch here, and we'll do a simulation to show what that is. That's called a peg to keep the part in there. If we cut that out, the remainder stock is going to fly out of it, could cause damage, could get stuck. We don't want to risk that, so we want to keep all the parts. We don't want parts to move until we're done with the project, right? And then same thing, we're going to cut to the outside. Now, whenever you do these contours or whatever approach you take to cutting, there's a bunch of different ones here. We're not going to cover them all. There's a lot of different strategies to cutting. In this case, contouring is a very simple one. It's appropriate for a lot of wood projects. We're going to simulate that. So we pick our part, and we go to simulate, and we're going to tell it what we want to simulate, and we're going to hit play, and you can change the speed. I'm going to go real fast, and you can see it's whizzing around, and we're like, did it really do what we want? And what we really want to get to is the very end, really what matters. And we're going to look at it in our 3D model, and we're going to say, is this what we wanted to make? Because if it's not what we wanted to make, then we need to go back and figure out what went wrong. This looks like we wanted to make, so we're pretty good with it. We're happy with it. Could be more efficient, but we're going to call it good. The next step is to export our operations. Now, I'm going to use this term very carefully. There's a lot of things that are called operations. I call an operation anything a human is involved in. So if I have to stop the CNC machine and do something as a human, that's a change in operations. Personally, I like my operations to be separate files. There are people who put pauses and stops and other things into it. I'm not one of those people. Could be easier, but it's not how I'm going to roll. So I have 2 operations for this project. I round over the edges, then I cut material out. When I do that, what I do is I pick the project I care about. I need to close the simulation. I pick the operation I care about, and I post-process. That creates what's called a G-code file. That's the actual instructions for the computer. It's literally a program for your CNC machine to run. And I have 2 of them for this project. And so we'll zero everything up, set it all up, we'll put the right bit in it, we'll zero the bit correctly, and then we'll run the first operation. When it's complete, we'll change bits, we'll load up the second operation, we'll zero that bit out. Zeroing a bit out means that the CNC machine knows where the bottom of the bit is, because that's important for jobs. Obviously, you have to tell the CNC machine where the part is in 3-dimensional space exactly. So we'll zero the bit out. When we're happy with zero the bit out, we'll run the second operation. When we're done with those 2 things, we will mostly have a sword rack. There's still some sanding and some clipping and some cleaning. So why don't we see what that looks like? We'll go ahead and do the construction phase, and then we'll talk over what we got. Admittedly, that was a simple project, and that's okay. For your first project, it should be simple. There's a lot to learn if you've never done digital fabrication before. You have to understand CAD and 3D design. You have to understand CAM and the whole idea around programming a robot to make work for you, because essentially a CNC machine is a robot. You then have to learn the machine, whether that's your first CNC machine, a machine at a makerspace, work, or school. Every machine's different and how they work is different, and you're going to have to learn that to be successful. The best way to do that is to pick a simple project and go from there. Now, was the sword rack my first project? No, not by a long shot. Was the sword rack you saw me make the first sword rack I made? No, not by a long shot. I probably went through 4 or 5 prototypes before I've made the 20 or 30 that I've made so far. That one being probably on the 30-year side of things. So it wasn't the first sword rack, and I did make mistakes even using 3D modeling. So it's okay to learn and experience. We all do that continually. Anyways, as always, thank you very much for your time. Thumbs up if you liked it, thumbs down if you don't. Even if you liked it or not, subscribe, make comments there. I think there's a notification thing. Click that after you subscribe so you get told when my next video is. I'd love to hear what you thought of the agenda format in the comments below. And as always, keep making, and talk to you later. Bye-bye.